Testing. 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 Waiting to see. Getting some audio here. Get started. Testing. Testing, testing. Testing. More testing. More testing. Okay, I think we're getting audio. We're doing good. All right. Welcome to another Hoopo stream. Today we're continuing on with the scroll prize. We've been working on this all week, and it makes sense that we have all this context loaded for this thing. We got to finish strong here. So we ran a bunch of hyperparameter sweeps yesterday. And not only did we run it on this computer, but we have another computer that also was running models. So the first thing we're going to do is we're going to copy over all the logs from that other computer into this computer so that we can look at them at the same time. So we're going to be using SCP. SCP is basically an SSH, but you copy files. So SCP-R will copy all the files from one computer into another computer, and we specifically want Venus output, and we want to copy that into here. Dev Venus output. Okay. Now these cut and put paste. So we have all of our training runs now. So if we hit refresh on the tensor board, we should get it. So these are all the different runs that we ran last night on 2 different computers and 3 different GPUs. So you can see here that roughly starts around 11 a.m. and then it roughly goes until 8 a.m. And let's go in step mode. See here, let's actually do wall. I like the wall because you can see how long they take. So you see here you have some training runs that take easily like 6 hours here, and then you have some runs that work very, very quickly. So let's actually go ahead and look at the ones that look at the predictions. So right off the bat, look at that. That is absolutely beautiful prediction. That is coming from this one here. Freeze, backbone, true. Atom optimizer, Swin-T transformer. Very good. Look at the next one here. This one failed out. This one did not good at all. This one failed out. This one, no good, also bad. This one, not that great. This one failed out. Oh no. Yeah, that one no good. This one, also no good. Ooh, this one very good. Not quite as good as that first one, but still pretty good. This one, kind of mediocre. This one failed out. And this one, also not as good. Okay, so we got one that's very clearly the best, this one here. And let's kind of confirm that that it's the best not only on the actual evaluation, but then also in the TensorBoard, because we want to make sure that the things that we're logging on TensorBoard are somewhat representative of the actual final performance. It's impossible to really know because we don't actually have ground truth labels for the test data set, so we don't know exactly how good it's doing. We can just like visually approximate based on how good the letters look, but can't actually know for sure. So the one that did well is this one here, 8857BF. So let's 8857BF. That's this one here. So this one trained from roughly 2:30 to about 4 p.m. So it trained maybe an hour and a half. And you can see that it got to about, let's see, it's this one here. So technically this one here, FEFA, this one, got a better score on 1. But it did not get a better evaluation. So from this, what I'm getting is that the data sets are tricky. So it seems like FEFA, did this one train on multiple? This one had 1, 2, and 3 as the curriculum. So you can actually see here, it did 1 up until here, and it did 2, and it did 3. Let's see, FFA. So this one got better on all 3 of them, but if you actually look at the prediction, it's not ideal. So it kind of seems like training on just dataset 1 is really how you're getting the best performance here. Let's see. Okay. What other ones can we investigate here? So I think one thing I wanted to train is backbone false versus true. False, true. So whether or not we're freezing the backbone. I really wish we could see this one here. 2B99. Yeah, this one never outputted something. But it seemed very promising. Okay. So a couple things to do here. Let's go into our, actually out of that as well. Exit out of this terminal. Let's bring over a terminal with terminal has our code. First things first, let's git pull actually. Okay. And right here where we evaluate, let's also evaluate on test B. Because I want to see if performance on A is correlated with performance on B, or whether they're basically independent. Let's look at Atom. Versus SGD. I feel like Atom is just way better here. SGD. SGD is really slow. And it doesn't get you anywhere. Okay, so one thing I'm learning, SGD, no good. Go into our sweep. SGD here. Trains slower and no. Comment that out. Let's look at the learning rates. So let's look at the gamma. So gamma of 0.1, 0.9, what about this red one here? This red one, 786. That's this one. No prediction. Good. It's like these training runs take so long that we can't actually get results for all of them, unfortunately. Gamma 0.9, and then what about gamma none? Gamma none, the only one that really seemed to perform is this one. Freeze backbone true. This is a convnext tiny. 3EC60. 3E. This one. So this is the one without learning rate scheduling and does not look good. Okay, so it's kind of looking like no learning rate scheduling, not going to necessarily be. Okay, image augs. All of these had false. Freeze backbone, true versus false. I think we still don't really know. It kind of seems like the freeze backbone true seems like the one. Bro, I can hear, but I can hardly see. Okay. About now. Is that a little bit better? I realize I need to zoom in. Okay. Going back. I think the curriculum 1, 2, 3, 3, 2, 1. I feel like let's still try it. A couple different ones here. And SimpleNet, let's get rid of SimpleNet. And let's continue here with our ConvNext Tiny, our ResNext, and our SwinT transformer. Patch size is correct. Batch size is correct. And here, the max samples per dataset, we can actually we can definitely tune this up. This is going to come down to how much compute we have available in the actual notebook, but ideally we can make this number as high as possible. Okay. So another thing I want to fix here is, you see how the UUID for this is all the way at the end here? I feel like it'd be more convenient if that UUID was all the way at the beginning here, right? Because then it'd be very easy for us to look at them. So I'm going to add, move this UUID and put it in the front, and I'm going to get rid of this run. I'm going to make run name UUID at the very front. And I also want to save the hyperparameter dict to a dictionary. Because the problem right now is that we can't store, like, we have the file names are so large that we can't put all of the hyperparameters in here. So I think what I'm going to do is inside this train valid loop, we have some code here that makes an output directory based on the run name. I think I'm going to copy this code out. So we're going to cut that out. Go to our sweep. Our run name. Make the directory here. We're going to need it for OS in here. Output dir run name, output dir exists. Okay, we don't actually need to pass the run name anymore. Get rid of that. I'm gonna make it a little bit smaller, man. It's very hard for me to code with absolutely nothing here. Let's get rid of this. No run name. Oh, okay. And let's save hyperparams file. Okay. So now our hyperparameters are going to be in a little text file that should be in the same folder. That should make it a little bit easier. Output dir here, we need to actually pass it this. Let's move some of these around here. So we have our directories, data sets, we have our model and training. Image aug, let's go up here. Slice depth, patch size, size ratio. Num workers, num epochs, max sample data set. Go. Just organizing these a little bit so it's a little bit easier to see. And I think that's mostly good, guys. Let's commit this real quick. Improvement or changes from sweep 3. So another thing I want to do here is eventually, up until now, we've been basically making these like little notebooks, right? Because ultimately we want to submit these to Kaggle. And when we submit these to Kaggle, we have to put them in a notebook format. But we've been making these notebooks kind of ad hoc and like copy pasting things. And ideally, I want to move away from that, right? I want to get to a point where I can just like copy paste a single time and get the notebook. So going to make this train function here such that you can pass it additional parameter, which we're going to call logging. This is going to be a Boolean, and we're going to make it maybe not logging. Conflicts with the Python module called logging as well. What do we call it? Log to TensorBoard, or maybe write logs. And the default for that will be false. We can see. And we'll have all this code hidden behind writer for TensorBoard right here. If write logs, then create this writer. Best loss step, curriculum, training, trainer, slice depth, resize ratio, train true. Raw dataset size. Let's change print. Logging doesn't work on notebooks. Image transforms. If image augmentation, add the horizontal and vertical clipping. There's probably more we can add here, actually. We can do a Gaussian blur transform. I think the thing with the transforms is like we're already not even getting through our whole data set, right? We don't need... Augmentation is useful if you have a very small data set and you want to train for a long time and you're kind of training too many epochs on a small data set. But this data set is so huge and our compute budget is so small that we don't really need to do augmentation. All right. Train data loader with a random sampler. Batch size, train data set, num workers. In the memory, make this print training of this, kind of cleaning up some of this code a little bit. Labeled device, model patch, image transform, loss function, backward optimizer step. Max samples per data set, and you get the scalar. Okay. Train loss, best loss, save model. Actually care about this. If learning rate schedule gamma is not none, seems fine. Evaluate on A and evaluate on B. with the output dir. Actually, that'll cause an error if we try to if write logs. That here. Okay. Our evaluation takes a model as an output dir. Slice depth, patch size, resize ratio, and a threshold. Slice depth, patch size ratio. Device, get directory, output, make output directory, get rid of that. Patch set. Actually, no, keep that. Train false, resize ratio, patch size X and Y, slice depth, dir. Fine. Thread image, NP heroes, eval dataset, resized size. Image. Sequential sampler. This. And let's also add timing, right? We were timing stuff here. So at the very top of our code here, we had a total train. So this, no more validation going on here. So call it train loop. Write logs. We'll also say run val false. And let's also add a max time. Hours. Say 8 hours of maximum runtime. Time train max seconds equal max times hours 60. We'll get rid of this. We'll also keep track of time elapsed time. Format. And let's in a separate tab here. Val. Then let's copy this time elapsed. here, if we're inside the curriculum training, inside the data loader, do we want to return? Yeah. Break. And here, I want to check the time limit again. Time limit exceeding, stopping batches, stopping curriculum, got my Doritos and landed to stream. Welcome. Hope they're delicious. Okay. So we have 3 different breaks here. We have the break for the data loader, or the actual batches. We have the break for the curriculum, and then we also have the break for the epochs. Yeah, so this is the code that runs every epoch, which is basically adjusting the learning rate. This is the code that runs on every curriculum, which is aggregating the training loss. And this is the code that runs on every batch of training data, which is right here. For patch, this is the tight training loop. All right, so we added the epoch. Let's add these in here as well. We're going to clear the GPU memory before we run the eval. Go into the utils, from utils, get device memory. We're going to need a copy paste. Clear GPU memory, get device. RLE. Utils, get device, RLE, write to submission. I'm not high. That's automatic eye following. So if I look anywhere near the camera, it'll automatically look at the camera. You can actually see it. If I go like this, you'll see it'll render the fake eye. Process. Here, GPU memory, import GC, garbage collect. Here. logging. RLE, we can. And I don't even think we write. Yeah. It's a little creepy. It doesn't really work with glasses, to be honest. And we also want the evaluation that we do here. Eval data loader, rate, from array, size, RLE. Oh. We're not going to put that in the used imports. Back to our train. Have our evaluate, and then we'll do evaluate or make submission. Output dir. Here's where we're going to put our can actually copy. In fact, pretty much all of this is the same. So copy this entire evaluate function, call it make. We have evaluate sweep. And we'll have if if write logs that, then why is the sampler not a thing? I guess we don't have one anymore. And we're gonna have two different types of eval. We're gonna have run eval sweep, and we're gonna have a run eval submit. Hope to see you get the scroll prize. We'll see. I don't know. It looks hard. I'm pretty excited though, because I think the one that we got, this one here is very clean. Like, look at that. That is super clean. I don't know what the score is, right? But have run eval sweep, then we have if run eval submit. evaluate submit. An eval dir. I think we need to add eval over here. Train dir, eval dir. And actually we can copy this code here that we had where we go through. Yeah, right here. Make subdirectory, name of subdirectory inside the tester. We can actually switch this around. We can. I quite like the Japanese people. The guy who's winning. Is he still winning? Let's see. Vesuvius, ink detection. Oh shit, he is winning. Look at that. He got a 0.66 score. He beat Igor. Damn, that's a high score. I think we'll get it. I think we can. Oh. If Valder, actually I don't even need. I'm gonna subtest name, subtest file path. If run eval sweep, evaluate sweep at subtest file path. If run eval submit, evaluate submit at subtest file path. Evaluate sweep and evaluate called make a blank prediction image. That's still the same. Data loader, that's still the same. Memory true. Normalize, that's also fine. Here is the actual code: patch to device, eval dataset, mask index I, torch no grad, put it sigmoid, predict. This part here, it actually, you threshold here. And this is the actual extra code that we part here. Resize prediction image to original size. Original image size X. I don't think that's that anymore now. Data set. Now we called it original size. Back to resize original size 0. Size. We're gonna need to import RLE for our utility. RLE from the image. We also need this part here. Data submit. If run eval it. Yeah, he's definitely won a lot of shit. We're up against some experts here. Run eval submit, create this file path, and not the one. Mission file path equals file path, and then evaluate submit, which is down here. And subtest that as well. Let's add that. Right. Sort. Oh, here, streaming this process. I appreciate it. I'm just trying to be open source. Anybody can just do what I'm doing. It's nothing secret about it. All right, let's close out of this. Don't save. So we added additional evaluation functions, one for the evaluation that we run on our sweeps, and then one for the evaluation that we run in our notebook that we're actually going to do submission on. Every day except weekend, yeah. Let's go back to our sweep, and we need to modify here as well, right? So here in the train loop, we also need to say run eval sweep equals true, run eval submit equals false. I think we added a couple other things we want to add here too. We want write logs equal true and max time hours 8. Okay. So we want write logs and max time hours. Write logs true, max time hours 8. Okay. So let's actually try to run. Go to our terminal. Let's remove the output. Right, we just got rid of all of our data, all that training for nothing. And let's see if we can run this sweep. We're going to run it test mode and see what we get. All right, there we go. First error. Local variable output dir referenced before assignment. Line 44 in sweep.py. Line 44 sweep.py. Output dir equals os.path output dir run name. Output dir is coming from where does output dir? I don't think we ever passed it in. Let's just make it a hyperparameter. H params output dir. And here we'll do data dash train and then output dir. And we'll do output. And I think we also had eval dir, right? That's something we pass now. Eval dir. Slash data slash eval. Eval dir. Eval dir. Okay, let's run it again. Let's run it again. Seems to be working. Okay, it's loading the slices. It's been a long time since I saw the cat. I don't know where it is. I could go get it. See, while this runs, I'll go get go to the back. All right, this looks like it's training. This looks like it's doing good. So close out of this. And let's see what the output dir looks like. Have our little hyperparameters .text, which is perfect. Not have any predictions going on there. Run eval submit, run eval sweep, true. Run eval submit, run eval sweep. Run eval submit right here. Subtest. Hash and data. Test, you got A and B. Run eval sweep. Evaluate model. Subtest file path, output dir. Subtest. Pass that as well. I think we also output dir, slice depth, test name. Fact that output dash eval. Output I don't think we need the output slash eval. Let's see, let's run this. Let's also do it with smaller slice depth, so faster depth of 2. Error, no such file or directory data eval. That's what's going on. Why is that? Because it's actually called test. Student actually called /test. Remove the output and run it. Right, this is the evaluation. Eval is actually like the longest thing. Weird to think about. I wonder if we can make it faster by doing batch. Right. Problem is that if we do it in a batch, we're gonna have to like batch this mask indices, and that's just really annoying to do. I think it's fine if we just let's see. Working local. Okay, another thing we need to do is the actual model itself here. We're gonna need to pass pre-trained weights file path. So fortunately, this is gonna make the code very gross. Basically, what we're gonna do is for these, we're gonna make a condition. Say if pre-trained weights file path is not none, and add it here. Back to our multi-cursor. And if the file path is not none, then we basically this, that we get rid of this part, and if trained weights file path is not none, load state dict. And we're also going to want to pass that in. So in our train function, we have our model, and then none. and we'll pass in variable. Do you still plan to do the other series of videos, speech-to-speech AI conversation app? Yeah, I kind of just abandoned that. It didn't seem like a lot of people were excited about it. And it's the type of thing that, like, there's a million other people doing that. And I even got some hate for it. Like, people sent me messages about the speech-to-speech, and they were like, you can't release this. This is irresponsible. I don't know. If you guys are interested, I could go back to doing that. Once I'm in terms of the scroll prize, I'm gonna run this sweep over the weekend, and then probably Monday we'll come back and we'll look at it, look at the results, and then maybe do a submission or two over the next week. But I don't know if I'm gonna be doing the scroll prize all next week. Seems like a lot. Support you. Thanks, man. Make a new file here. Call it 08. Call it the new deal. This. Right, in our new deal, we're gonna copy paste all this crap here. Paste it in there. We'll add one code cell, and inside that code cell, going to put all of the relevant code. So we're going to have our pre-trained net. Probably going to have to do torch vision models, functional. This is slowing down. This, that, there. put in our data loader. Patch data set. Copy. Paste. Also want the training evaluation. This train loop here. And I guess we're doing evaluate sweep and evaluate submit. Add these as well. We also need our utilities. We also need to add our utilities up here. Our patch data set, we have our train, we have our evaluate sweep, evaluate submit, all of our utilities. And then I think the last thing we need here is model itself. That in there. And not simple. Why not simple net? Okay. So now we should just be able to copy paste this entire thing into Kaggle. So just some of these that we don't need here. We need matplotlib. I guess we don't need random, we don't need blob. Then here, where we put ink detection train, ink detection test. Okay. Output dir shouldn't matter, but let's just say output. These two deleted. Curriculum, let's say 1, 2, 3. Image augs, we'll say true or false. Resize ratio, we'll say 0.25. Workers, we'll say 1. Max samples per data set, we'll say 80,000, or actually 100,000. Models and training, we'll say conv next tiny. Freeze backbone, we'll say true. Optimizer, we'll say atom. Learning rate, schedule gamma. here we'll say 0.1 or 0.9, sorry. Slice depth, of course, 65. Patch size X, 224. And patch size Y, 224 as well. Batch size, 64. Learning rate. That. Epochs, 6. Max time hours, 8. Run eval sweep, false. Run eval submit, true. And then write logs, false. Okay. Why is this not happy? Okay, so clear all outputs. Something is running. All right, see you later, Biggie, man. Fuck. This. And let's see if we can just run this code here, right? Debug it before we put it into (100) slice depth. We'll say 2. Box 2. Write that. Run that. Name error. Learning rate scheduler is not defined. Model. Need to or learning rate schedule from Optim. Import that bad boy. Log is not defined. All right, where's our log? You know what's an even better way to do this? Let's fucking get rid of that. I'm changing my mind. I feel for the longest time I was all about Python logging, but now I'm thinking, you know what? Fuck that. It's prints are just easier. So let's do Control-Shift-H, and we're going to search for log.info. We're going to replace it with print. And then log.debug, we'll replace it with. Let's not do it in some of the early. That also means we can get rid of this deep copy. And yeah, let's run that. Log is not defined. Come on. In train loop. Overwrite. Place log dot info with print. Transforms is not defined. I think we need to import torch vision transforms. Training CUDA out of memory. Tried to allocate 16 megabytes. It's no good. Why does it take more memory here? Gotta do batch size of 32. CUDA out of memory with 32 batch size. Come on, that's tiny. Fuck. Oh. Like batch size 8? Is that fine? Like CUDA out of memory again. Alright, something's wrong. Something's wrong. This isn't right. Let's look at our... Okay, you see the problem here that our GPU still has all of the memory. So the memory hasn't been cleared out. I think the problem is that this Jupyter notebook is not restarting. So I think if we hit clear all outputs and restart. Yeah, you see now it's empty. What we wanted. Okay. So let's go back to a batch size of 64. Fucking Jupyter notebooks don't release the GPU memory. Bad news bears. CUDA out of memory. Guys. Why don't we use our clear GPU memory, and let's put that at the very front here, or at the very beginning of our train loop. Device get device clear GPU memory. Restart all outputs. Clear all outputs, restart, run all. On train, train, train. Okay. Now it's doing the actual prediction. $675,000 inferences to run. Take over an hour to run. Dude, what the fuck? Let's see if ChatGPT can vectorize this. kill this. Corrupt. All outputs. What? What? Can't do this to me. I'm a fucking plus subscriber. I don't understand. On. It's a clear R. More tools. Clear browsing data. Clear data. Hopefully if we clear the cookies, maybe it'll work. Log in. Why? Why? Why must it be this way? In the meantime, up some of the crap. There's a lot of crap in here. This, that, that. We don't need that. We don't need that. We don't need that. 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 Delete. New Deal notebook. Okay. Actually, I want to compare them. Work with a different patch size. All right, dudes, I think this is good to run. Here's what we're going to do. Got our curriculum. Also do one. Prepare for 3. Or what is it? It's like sweep like 10 now at this point. This here, that there. Keep that there. Right. Pretty much good. I think I'm gonna run this sweep over the weekend and then what happens on Monday. Either way, thanks for watching. Hope you guys had a good week. Hope you guys have an even better weekend. And wish y'all the best.